Hello, welcome back everyone. The last video I have explained you about basic proportionality theorem, which was also known as Thales theorem. In this video we will learn converse of BPT, converse of Thales theorem, right? So as I repeat, we are talking about converse of BPT, basic proportionality theorem, and this BPT is also known as Thales, so I'm writing converse of Thales theorem. So what is the statement of converse of BPT? If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Please don't get confused between this theorem and midpoint theorem, which you have studied in 9th standard. Right, so I repeat, statement is if a line divides any two sides of triangle in a same ratio, then the line is parallel to the third side. That means I'm explaining the statement through the figure. This is any triangle. Let's say this triangle is A, B, C, and we have to prove that this is, let's say, this is P, this is Q, right? So what they have given for this one, they have given that we have AP upon PB equals to AQ upon QC. This is given to us. What we are supposed to prove? We need to prove PQ is parallel to PC, right? So as we need to prove PQ is parallel to PC, right, here again I repeat, this is converse proof, so we need to use indirect method of proving. So let's start with the proof. Let PQ is not parallel to BC. If PQ is not parallel to BC, then there exists line PR parallel to BC. That means in this figure, what we are assuming, that PQ is not parallel to BC. Okay, so we need to assume that from here some line, let's say this line is PR, which is parallel to BC, right? If PR is parallel to BC, right, through the figure, definitely you must be thinking that PR is not parallel. Just we are assuming that PR is parallel to BC, right? So as PR is parallel to BC, right, therefore by BPT, that is by basic proportionality theorem, in this figure we can write AP by PB equals to AR by RC. I repeat, we can write by BPT, we can write AP by PB equals to AR by RC, right? So let's label this given as 1 and this as 2, but already what we have, AP by PB equals to AQ by QC. This is given to us, right? So from therefore what we can get from 1 and 2, or from these two, AP by PB is common, so we are getting AQ by QC equals to AR by RC. I hope this is clear to you all. I repeat, as these two are equals to AP by PB itself, therefore we are getting AQ by QC equals to AR by RC. So when you say this, if I apply componendo, right? What is this componendo? First of all, componendo is, again, it's a property on ratios, where if you add denominator to the numerator, both sides will remain same. Or if you don't want to apply componendo, we can write simply adding 1 to both sides. So this is aq by qc plus 1 equals to ar by rc plus 1. So this can be written as further aq plus qc upon qc equals to ar plus rc upon rc. So when you see the figure, what we have, aq plus qc, aq plus qc is nothing but ac, and what we have again for ar plus rc, again ac. So for both the ratios, so the denominator must be same. That means this will become ac by qc equals to ac by rc. So ac cancel on both sides, so you are getting 1 upon qc equals to 1 upon rc. So therefore what we are getting? We are getting, from here only I am writing, we are getting qc equals to rc. So when you see the figure, we are getting qc is equals to rc, and this is possible when q and r both coincide each other. Means when q and r, they are same point. So what we can conclude from here, we can conclude that this is not possible. This is only possible when, I repeat, this statement qc is equal to rc. It is possible only when q and r coincide. That means they are not different point, they are same point. Therefore what we can conclude, our assumption is wrong. Therefore what was our assumption, friends? Our assumption was PQ is not parallel to BC. As our assumption is wrong, therefore what we can say, therefore PQ is parallel to BC. Hence the proof. This is what we wanted to prove. Let's quickly revise what we have done. Right? This is converse of BPT, and converse of BPT as per the statement, if a line divides the two sides in the same ratio, then that line is parallel to the third side, which means if AP upon PB is equals to EQ upon QC, then we have to prove PQ is parallel to BC. We are assuming PQ is not parallel to BC. If PQ is not parallel to BC, then there exists another line PR which is parallel to BC. And if PR is parallel to BC, try to understand, if PR is parallel to BC, therefore by BPT we can write AP by PB equals to AR by RC. Same thing we have written over here, right? But already what we have, AP by PB equals to AQ by QC. So equating these two, we are getting AQ by QC equals to AR by RC. Adding 1 on both sides, we are getting AC by QC equals to AC by RC. AC cancel on both sides, right? So we are getting QC equals to RC, right? It is only possible when Q and R coincide, right? Therefore our assumption is wrong. Therefore what is given, that is PQ is parallel to BC. Hope you have understood this converse of BPT. right? Hope you'll like it. You'll share it with your friends. Thank you so much for watching this video. Thank you.